Hello, my name is Nathaniel Osgood. Within this video, we're quickly going to go over the basic steps required to compile and run a bit of Java code that depends on an external library, type of library that can be readily downloaded as a jar file, such as by Maven or manually from a repository. So to start this off, we have within a folder a piece of Java code, in this case a single file. I'll comment how it would generalize to multiple files. We have the jar file, which captures a library that we'll be using, and then we have an input file which will be used by the program that will be running when we get to the point to run it. Okay, the first thing I'm going to do here is I'm going to create a build folder. This build folder is going to hold the results of compiling this code, which it turns out will consist of a set of .class files. We put those in a build folder just so they don't clutter up our space and get in the way of seeing the relevant files. So we're going to use the build folder to hold the results of the compilation of this code that's going to stay in our folder. Separately, I'm going to create a jars file, which I'm going to use to hold the particular jar that we have here. In general, it could be used to hold multiple jars. Say your Java code depended on multiple jar files, you could put them all there. Okay, so having done that, we are in a situation where we have a jar subfolder, a build subfolder. The jars holds the libraries, the builds holds the output from the compilation. Now, what we're going to do is we're going to use the Java C command. This is the Java compiler. The C stands for compiler. And that compiler is going to take care of translating those Java code into a runnable form, into so-called bytecode that's captured in one, or in this case, multiple set of so-called .class files. I'll also comment how it could be Java compiler. Okay, look, I'm going to want you to compile something. And the output from that compilation step, the output from turning that can be run, that should be put in the build folder, in that folder I created here. Okay. The next thing we have to do, and this is critical, we have to tell it about the libraries we depend on. These libraries are located in jars, but it doesn't know that up front. So we're going to tell it, okay, look, go and look at all jar files, hence the star, in this jars subfolder, this one we created, which of course held that jar file that used to be here. So this is telling it, okay, we're going to do the compilation, put the output here. We're going to use the so-called libraries, the jar files, to perform the compilation, which are located in this place. And the final thing we have to give it is information about which thing we want to compile, which is, of course, our Java file here. Now, if we had more than one Java file, we could, list them as well. So we could list, file 1.java, file 2.java, file 3.java, and we could do them all at once. We could even do star.java to compile all the Java files at once. Java compiler will happily go through them and use the same jar files to know how to build them and put their output here. Right now, we have a single file, and so we will perform the compilation. Now, this compilation is going to go through this Java file, and because we've told it where to find the libraries, the so-called jar files, it's going to be able to handle things within our Java file that depend on these external libraries. So if I'll say less at Conway's Game of Life here, you'll notice, for example, there's an import here, not only of standard Java stuff, which it knows about how to get, but we're importing things from this Apache's common location. And in order to figure out how to import those and it turns out we'll be using them elsewhere in the code. For example, here we declare something. We create an instance of an object here, or we're manipulating an instance of an object which is of a type which lives in that jar file. It will know how to handle that. And when we use that object here, this iteration count and rule pair, and we call getRight, it needs to know, what does that return? What does getLeft return? In order to know this information, we have to tell it where to find those jar files when it compiles them. Okay, so that's what this option is all about. Saying compile our code, one or more Java files, but knowing all about these libraries that are described in this jar file. For example, what method calls to those libraries return within our when they're used within our code. That's why it needs to know about those jar files at this point, so it can compile our code. So we we built it, and by building it, it doesn't seem at first glance anything has changed. But if you look in builds, you'll find that, oh, okay, within build, it actually created a bunch of class files. Not just one, but class files for several classes associated with this source code. And if we look in the source code, we will find that, in fact, for example, there's not only a Conway's Game of Life class, but a compute liveness rule. It's an interface, and that actually turns it into a class file. Okay, .class file. Similarly, these nested classes are declared within our code in other places. So they're way down here. I'll do less here so I can go up a few lines if I get to the end of this code. But here's a static class, compute liveness, remain alive 1 through 3, and you'll find that that's one of these internal classes. Okay, so that was in our code here, and that was in our code in a way that allowed us to use it within our Java code, but it did so in a way that was a nested class, a class within a class, the static class, and that's all appearing within the broader confines of an overall Conway's Game of Life class that contains it, and hence Conway's Game of Life $ this. So these are other classes which are in our code, those in the compute liveness rule, that it turns into class files. So it's not always the case that one Java file turns into one class file. So where do those live? Those live in build. We put them in build because we didn't want to see them clutter up this space. So that's step one. We've compiled it. We've turned our Java code into a set of class files, bytecode files, files which now can be executed. So let's proceed to execution. In order to execute them, we're going to perform a Java command. Now this Java command is different from the Java C command that we performed earlier. Earlier we said Java C because we wanted to perform a compilation of our Java code. That compilation is done. We now have a bunch of .class files. Now, ladies and gentlemen, it's our turn to use those. Those are the runnable files, the files that collectively can be run. And we're going to tell the Java virtual machine, the thing that actually runs Java bytecode, how to find them. And, importantly, how to find the things on which they depend. So in order to do this, we're going to tell Java about a class path as well. You notice before when we did Java C, we told it about a class path, where to find the jar file. So it knew all about those things that our Conway's Game of Life was calling externally, those things in the libraries. It needed to know about those things so it could compile our code. Now our purpose of telling it about this class path is so we can actually call these external libraries, not just know the information about them needed to compile our code, but to actually call them from our code, from our bytecode. So we're going to tell them about two places. We're going to tell them about our class path in build. That's where we can find our classes. But we're further going to tell them about here about the things that are in the jars. And in this case, we're not going to be able to nicely do / jars star.jars, because it turns out that in Linux that star is not going to be properly expanded into file names. So instead, we need to do actually typing the name of the jar. So this is actually the jar that lives within that jars folder that we created before. So we're telling this class path, hey, look, when you're trying to find things to call, go look in the build folder. That's where we have our class files. And then also go look in this jars file where there's this commons lang 3-3.4.jar. This is not a particularly privileged sort of name. It just happens to be the one that we're using from our code. If you had more of them, you do colon, jars, foo.jar, and for example, colon, jars, bar.jar. Those would be additional jars that you could use in the same sort of way on the class path. But we have only one jar, so we will leave it to this. So that tells it where to go to find this stuff. Now we have to tell it what main class to run. Where do we want to enter the program? What's kind of the point to look for to start to run the program? And it turns out it's this Conway's Game of Life is the class associated with that. If we created a class called main, which had the appropriate method in it, which I'll be showing you in a second, we'd put main. If we had a class called foo that had that main method that we'd want to start at when we run the program, we'd put foo here. Okay, so here we have Conway's Game of Life, and then we'll give it any arguments that we want to run it with. Say how many steps to run it. Okay, I'm going to tell it to run it for 10,000 steps, and now it's going to call off to Conway's Game of Life. It finds it and builds. It realizes it's calling things in this jar file, like that immutable pair that it was using, and so it goes and finds them here. Let's suppose that we forgot to tell it about the jar file. What would happen then? Well, it would start to try to run our program, calling Conway's Game of Life, enter the main method, but it then wouldn't be able to find the stuff that lives in commons lang 3.34. We'd get something like this, where it actually starts it up. It starts at main, it calls simulate, goes to determines arguments, and then it said, look, I can't find the immutable pair class. Okay, why can't it find it? Because we didn't tell it about the jar file where that class lives. And after all, if we go to the Java code here, if we go to the Java code, it depends on this. Where does it depend on it? Well, in our Conway's Game of Life, if we go and we look at immutable pair, for example, we'll find that we're getting it from this determine arguments, okay, determine arguments, here we go, determine arguments, and determine arguments in turn goes through here and it creates a new immutable pair. And not surprisingly, that's where it dies. It's at that point where it's trying to use this thing, immutable pair, this class that cannot be found, and it can't find it because we haven't told it where to find it, in what jar file. In order to do that, ladies and gentlemen, we go back to that. That's why this is so critical. When we did Java C, that class path was used where to find information about the things in the jar so that when it's building our Java file, it knows what they return and so on. Here with Java, we're actually needing to know about that jar file because we need to call it. We need to find it so we can actually call it and enter it. And here it goes. It runs just fine. So, ladies and gentlemen, our build contains these classes, and this is telling us basically to run the stuff in build using anything that's provided in this jar file. And it's telling Conway's Game of Life. Why Conway's Game of Life? Because I said that was the main class, the class that contained the main method. And there, ladies and gentlemen, here we see public Conway's Game of Life. And here, ladies and gentlemen, is the main method. Public public, so we could see it from outside. Static, there's one for the whole class, not for each instance of the class. Void, it doesn't return anything. And main, it takes strings. These are the so-called command line arguments, the things that are given to it when we run it on the command line. So this is the main method. This is the starting point of our program. And we told it to start that place because we told it to start at the class Conway's Game of Life, and it knows, hey, within that class, look for a main method. This is the argument that it's getting. In this case, it's 1, but we could give it separate arguments, foo, and etc. Okay? Okay, so here we are, ladies and gentlemen, running the items which are in this build class. We're going to finish up with one final thing here. We're going to go into build. Ladies and gentlemen, we're now in build. Sometimes it's useful, instead of having this kind of cacophony of different builds, sometimes it's useful to package them all up into a jar file. Ladies and gentlemen, doing so would allow you to take that jar file and, for example, place it in different places which would where it might be useful, instead of always having to point to your build folder with all these classes. So one way to create that jar file is to do a jar cvf. These sort of commands are shared with the tar command to create a so-called tarball, sort of an archive. So this Java archive, created by jar, Java archive, hence the name. So portmanteau of Java archive. Here we'll say, okay, create the Conway's life.jar using all these class files. And it will go create, tell it what's in there, and add those things in, compress them, and create a Conway's Game of Life jar. And if we wanted to, we could go put that in our jars file. Then we wouldn't have to refer to the build folder, just to Conway's Game of Life. For example, we could move from the build folder, the thing we just built, Conway's life.jar, and we could move it into our jars file. Now our jars file is contain not only this external jar, but Conway's Game of Life.jar, and now we could actually do a compilation that doesn't have to worry about this build folder, but instead just things that are in there. Okay, so in order to do that, though, we're going to have to tell about more than this Conway's Game of Life.jar. Sorry, the commonslang.jar. We also have to tell it about jars and our Conway's life.jar. Okay, and now it works fine because it's finding the equivalent to those class files in a different place, namely in this jar file that we placed within our jars folder just now. So we can either refer to our classes in our build folder using syntax such as this when we go to run it, or we could bundle them up into a jar using this so-called jar command, put them in a jar file, and then we could put them in wherever places. As long as we referred to it, that jar file, boom, we can make use of them and could call off. We don't always have to refer back to our build folder. Ladies and gentlemen, it's been my great pleasure to characterize for you the basics of compiling and running, compiling with Java C, running with Java programs which depend on an external library captured as jars. And we've seen that through the use of the Java C and Java commands for compiling and running respectively, and by referring class path parameters to the appropriate jar files as well as to any of our code for Java, we can then compile and run our code. Okay. Thank you very much. I'm grateful for your time.